So here we have y, which is given by an inverse tangent function. We need to obtain the derivative of y with respect to x. To begin with, let us consider the given function. So here we have y equals to tangent inverse of square root of 1 plus x squared plus square root of 1 minus x squared divided by square root of 1 plus x squared plus minus square root of 1 minus x squared. So what we'll do, let's label this as number 1. We'll try to simplify the expression within the parentheses by using a trigonometric transformation. All we have to do is make it into a tangent function such that when we take tangent inverse of that tangent function, it will simplify. Fine. So what we'll do here, we will consider x squared to be equals to, let's say, cosine of 2 theta. If we take x squared to be equals to cosine of 2 theta, then 1 plus x squared, that will be equals to 1 plus cosine of 2 theta. Now we know this is an identity, 1 plus cosine of 2 theta, which is given by 2 times cosine squared theta, that is the value. And when we take the square root, then square root of 1 plus x squared will be equals to square root of 2 times cosine theta. Let's label this as number 2. Then we will take 1 minus x squared, our value, which will become equals to 1 minus cosine of 2 theta. So 1 minus cosine of 2 theta will be, this is an identity which will give us the value 2 times sine squared theta. So that means when we take the square root on both sides, we have square root of 1 minus x squared, that will be equals to square root of 2 times sine theta. We will label this as number 3. Now what we'll do, we will substitute 2 and 3 into equation number 1. So now our equation 1 will become y will be equals to tangent inverse of, now in the numerator we have square root of 1 plus x squared, so that becomes square root of 2 times cosine of theta, plus we have square root of 1 minus x squared, so that will be square root of 2 times sine theta, divided by square root of 2 times cosine theta minus square root of 2 times sine theta. Now what we'll do, we'll divide each of the terms in the numerator as well as the denominator with square root of 2 times cosine of theta, which will give us now tangent inverse of 1 plus, so when we divide square root of 2 times sine theta with square root of 2 times cosine theta, we get tangent of theta. Similarly, in the denominator, we'll get 1 minus tangent of theta, which will be now equals to, now we will make a manipulation here. So what we'll do, we know the tangent of pi over 4 has a value of 1. So what we'll do, in place of this 1, we will replace it with tangent of pi over 4. And in the denominator, we have tangent of 1, which can be also represented as tangent of theta times 1. And we can replace that 1 value with tangent of pi over 4, such that we now have tangent of pi over 4 plus tangent of theta divided by 1 minus tangent of theta multiplied to tangent of pi over 4. Now we have done this because we know there is a property of tangent which says that if we have tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B, so this is actually our function tangent of A plus B. So in our case, we have A, which is equals to pi over 4, and B value is theta. So that means we can rewrite this expression within the parentheses as tangent inverse of tangent of A, which is pi over 4, plus B, which is theta. That means now we have y equals to tangent inverse of tan of pi over 4 plus theta. So we have successfully converted our expression into a tangent function. Now we have y equals to pi over 4 plus theta. To begin with, we started by considering x squared to be equals to cosine of 2 theta. So this means that 2 theta must be equals to cosine inverse of x squared. But we need theta. So that means theta must be equals to half cosine inverse of x squared. Therefore, we can say y will be equals to y pi over 4 plus half multiplied to cosine inverse of x squared. Now all we have to do is find out the derivative on both sides with respect to x. So we have derivative of y with respect to x equals to derivative with respect to x of pi over 4 plus half being a constant, we'll multiply it to derivative with respect to x of cosine inverse of x squared. So pi over 4 is a constant, so its derivative will be 0. So we have half multiplied to derivative of the cosine inverse function, which has a standard value of -1 divided by square root of 1 minus x squared. So here x is x squared. So that means we will need to multiply it to derivative with respect to x of x squared using the chain rule, which gives us half multiplied to -1 divided by square root of 1 minus x raised to the power of 4. The derivative of x squared with respect to x is 2x, and therefore our final answer will be derivative of y with respect to x is given by, so here's 2 and this 2 goes away, so we have -x divided by square root of 1 minus x raised to the power of